Since announcing the private preview for Terraform Stacks at HashiCorp, there's been a lot of excitement building around one of the biggest changes to the Terraform workflow in recent years. Stacks introduces a new configuration layer, which sits on top of Terraform modules to allow multiple modules to be composed and modified in the context of a larger provisioning and deployment system. To talk more about Terraform Stacks, I'm in the studio with Sarah, who works here at HashiCorp as a product manager for Terraform. Thanks so much for being here.
Thanks, Jordan. It's great to be here since we've been talking with our customers, and we've seen them struggle with some challenges around managing their workspace complexity in Terraform. We noticed there were often scenarios where we would see users writing additional automation on top of their Terraform configurations to better manage multi-workspace workflows. After digging in, we identified two key challenges they were attempting to address. The first challenge has to do with dependency management, which is something Terraform does really well within a single workspace. Terraform builds this graph of dependencies and plans and applies everything in the configuration in the right order. However, the challenge developers face is when dependencies don't all live in one workspace.
In a perfect world, we can manage all of our infrastructure with a single Terraform configuration. However, as you probably know, there are a number of reasons why you should have to split your infrastructure across multiple configurations. These could be things like keeping infrastructure components with different provisioning lifecycles separate, reducing long runtimes, or separating code across team boundaries.
Exactly. There are a number of reasons to keep things modular. This is where we find users making trade-offs between either putting as much of their infrastructure into a single workspace to take advantage of Terraform's native dependency management, or splitting infrastructure across multiple workspaces and managing those dependencies manually or with some custom tooling. The second challenge comes when we start having to repeat workloads, since there may be times you need to duplicate workloads, whether that be across development, staging, and production environments, or multiple cloud regions, resulting in a bunch of workspaces that have to be managed independently.
So we covered some of the challenges that Terraform developers face, but the vision of Terraform Stacks is a new approach to provisioning and managing your Terraform configurations.
Stacks replace the root module in a standard Terraform configuration with a new configuration layer that makes it possible to describe not only what you want to provision, but how and where you want to provision it. In a stack, you describe the what by declaring components, which each reference a Terraform module. And then stacks have deployments, which tell Terraform how you'd like this collection of components deployed, making it possible to repeat your infrastructure without needing to repeat your code. Instead of manually creating a number of workspaces every time you want to spin up a new environment, stacks make it so all you need to do is add a new deployment block into your configuration, define the corresponding inputs, and the stack will take care of spinning up the required infrastructure for you. Stacks also allow you to define what are called orchestration rules to codify the approval and rolling out of changes across these repeated infrastructure instances. And then when it comes to managing dependencies, stacks have a couple of options. Terraform modules that share a lifecycle can be organized and deployed together as components to take advantage of Terraform's native dependency management. Additionally, multiple stacks can be connected together where relevant changes from one stack will automatically initiate operations in another. No bash scripts required.
So now that we covered this new approach with stacks to provision and manage your configurations, I think, Sarah, we'd love to see a demo of this working in action. Could you show it off?
Absolutely. Let's go ahead and start out with a fairly simple stack that I've already deployed. Here I have 3 deployments, 1 disaster recovery deployment, 1 East Coast development deployment, and 1 production deployment. Let's click in and take a look at the East Coast dev deployment. Looking at the current state of this deployment, we can see it has 3 components, 1 for API Gateway, 1 for Lambda, and another for an S3 bucket. This example is quite simple. These infrastructure pieces don't necessarily need to be written as separate components, but when we do write them out separately, we get the benefit of being able to see the states and resource diffs broken up by component. I'm going to switch back over to the production deployment since it's slightly different. In this deployment, I have twice the number of each component, a US East 1 and a US West 1 copy of each. Let's take a look at the configuration that makes this all possible. There are two main parts to a stack configuration. The first is the .tfstack.htl files, which include my provider and component declarations. Here I've declared 3 components, one for S3, one for Lambda, and one for API Gateway. For each component, I use a module as a source. You can source modules from all the same places you normally source modules from today. In this case, I'm using a local module within my repository here. Then I just need to declare the component inputs, which can be outputs of the previous component, and pass in the provider configurations to use for each component. This configuration also uses the for each meta argument for providers and components, passing in a list of regions. Switching over, the .tfdeploy.htl files are where you declare your deployment blocks and specify the input values for each deployment. In this case, I've declared the 3 deployments we saw earlier. We can see that the production deployment specifically has 2 regions declared here, which is why we saw twice as many components showing up in that deployment. Let's see what happens when I add in another deployment, West Coast Dev. I just need to drop in a new deployment block for West Coast Dev with the correct input variables. I'm going to commit this directly to the main branch and avoid going through the pull request workflow to speed things up. We can see a new configuration version, configuration 2, has been created for this commit. Let's dig in. This view shows additional information about the configuration changing, including a full list of plans for each deployment. It looks like the West Coast Dev plan has completed. I can open up the quick view to take a look. I can expand each component to get an idea of the resources being added in this case. I have the choice to approve this plan, but I'm not going to do that at this time. I can also see for a remainder of the deployments that there were no changes and each of them are still up to date with the newest configuration version. I talked a little bit about orchestration rules already. Let's take a look at what one of these looks like in action. Orchestration rules also go in one of the .tfdeploy.htl files. I'm going to go ahead and edit this file again and drop in an orchestrate block. The type of orchestrate block we're going to use here is an auto-approve block. This means that for a given deployment, if all of the checks that are in this block are met, the deployment will be auto-approved. In this case, I'm only going to auto-approve a deployment if no resources are being removed in the plan and the deployment name is not production or disaster recovery. Now to see this in action, I'll also need to make some sort of change. I'm going to come over to my Lambda module and make a small change that will result in some resource diffs. We can see that configuration 3 has started to plan. Most of the plans here include the removal of resources, and therefore they were not auto-approved. Using the quick plan view, I can review each of these plans and approve them in sequence. In our new West Coast Dev deployment, we can see that it has started applying. Clicking into the plan, we can see that an auto-approve event was triggered for the rule safe plans. This is a really useful and powerful way to avoid manual operations.
Well, thanks for the great demo, Sarah. It's great to see how Stacks enables scaling infrastructure effortlessly. For those of you who are looking for more information on Terraform Stacks, the link on your screen will take you to the blog where you can learn more. Stacks is currently in private preview. If you get in contact with your account team or contact sales, you'll be able to get access and try Stacks out today. Thanks everyone so much for watching, and thanks Sarah for being here.
Thanks, Jordan.